Hello everyone, welcome back to another video. In today's video, we'll be looking at the CMOS 1500 TVL mini FPV camera. It is one of the first cameras which pop up when you search for FPV camera with OSD. It comes in an unbranded box which looks something like this. Is it even worth to buy it? That you can decide by the end of this video. The camera itself comes with this OSD setting control module. The camera is type CVBS, which is a fancy name for saying it's an analog camera. Hence, it has three wires. One is for VCC, which technically supports 5 volts to 30 volts, at least according to the documentation. It has a ground and the composite out for the video transmission. To view what the camera sees, we will need to have an analog system, which involves an analog transmitter and an analog receiver, which are the most basic components you will need to start off if you want to fly FPV. I'll be making a more comprehensive video about the transmitter and receiver in future. However, here we have TS835, which is a 5.8 GHz 600 mW 48 channel analog transmitter capable of transmitting analog video up to 2 kilometers. To connect the FPV camera with the transmitter, you get a wire which looks something like this. It has 2 positive and 2 ground, and another cable which runs composite video from your FPV camera to the transmitter. Connect the antenna before you plug in the power. Well, if you intend not to fry your transmitter instantly. And here is the confusing part. If you have an FPV camera like the Firefly systems from Hawkeye, it comes with a mini USB Type B connector and are usually self-powered because they usually contain DVR. In such type of systems, I'll never recommend you to use the positive connector because any voltage more than 5 volts will instantly fry your camera. However, it has to be noted that the negative connector should be connected to the same ground the transmitter was connected to. However, in today's video, we'll be going through this mini FPV camera in detail. Here I have a mini breadboard which just fits in with the mini FPV camera, which will help me to make the power rails, one for the positive and another for the ground. When all connections are done, the breadboard will be supplying power both for the FPV camera as well as the transmitter. Not to forget the connection for the composite video which directly runs from the FPV camera to the transmitter. And more importantly, as aforementioned, we will have to give a common ground connection both to the FPV transmitter and the FPV camera, which is quite simple in our case because we are running on one single battery for both FPV transmitter and the camera. However, it will not be that simple if you are using multiple batteries. In that case, you will have to connect all the common negative terminals to have a common ground. Before we move further on, we will just have a recap of the power connections. It doesn't matter if you have positive terminal connected to your camera or not, both of the negative terminals should be connected to a common ground. In cases of your FPV camera being powered internally, you will still have to have the negative terminal grounded to the same negative terminal your FPV transmitter is on. Connecting this system to the battery is pretty straightforward. I'll be using the balance lead connector to connect both the FPV camera and transmitter. In the balance connector, I'll be connecting the positive and negative 2 pins apart, which will approximately give me 8 volts of maximum voltage, which is well under the voltage limits that the system can take in. Once you have connected the battery, provided you have done the connections right, you should see the channel display on your transmitter. Depending on the type of analog receiver which you will be using, you will have a different mechanism to search the signal which the analog transmitter would be transmitting. But in general, all analog receivers are capable of automatically searching and locking to a specific signal which is being transmitted by your transmitter. You can also brute force for different channels which your transmitter will be transmitting for a better signal quality and strength. The latency of the system is pretty much nothing. You will almost receive the same video what the camera is capturing. Just in case, if you were wondering, if you lose connection or if your channel changes, you will see a black screen. However, if there is any damage to the transmitter, you will see a noisy white screen. Coming to the OSD settings, you can change the settings using the joystick which you get with the camera itself. Going to the OSD settings, we have multiple language options. In video settings, we can see the camera is of type CVBS, which is simply means composite video, which is the only option we get. However, we get an option to choose NTFS or PAL based on the flickering frequency in your country. According to me, the image enhancement setting is where this camera gets all its swag and fashionable confident appearance. Almost all settings like contrast, sharpness, saturation are dynamically adjusted based on the scene directly by the camera. Well, you can set it manually, but the camera does a really good job of adjusting automatically. As FPV cameras do, even this camera supports day-night mode where you have black and white, EXT or color mode. The camera also supports auto white balance mode and auto exposure mode. For me, in auto white balance, the grey world seemed to be realistic and naturally appearing. However, for the exposure settings, I would recommend a brightness of 60 and exposure mode to FLC. Thank you for watching the video and happy flying.